Hello guys, now this is the section where we are going to discuss why some components are installed in the pipeline. So since in the previous section we had seen the pipeline diagram for built system, in this section we will see why some components are installed. So first question is, why is a siphon breaker? You can see this is the siphon breaker here. Why is it installed in the OWS overboard line?
To every marine engineer out there, from junior engineer to chief engineer and electrical officer, we all know that earning respect on ship is very important. We all know fast promotions are very important, and we all know that इज्जत कमानी है, promotion चाहिए तो काम आना चाहिए, तो जूते पड़ते हैं, गालियां पड़ती हैं, and for that you need a good mentor. Sometimes we keep finding those mentors on board ship, अगर नहीं मिल रहे तो MNDFLIX है ना, Merchant Navy Decoded has launched a subscription model where you can find more than 30 plus courses with respect to your rank, helping you earn respect on ship. Please enroll on these free trial videos, watch these videos as per rank, and then decide whether you want to invest or not, with a very good flexible payment plan as well. Jai Hind, Jai Bharat, Jai Mata.
Okay, so the concept is, it's like just like drinking up something from a straw. If you are creating vacuum, fluid flows out from the bottle and comes to your mouth directly when you are sucking it up. So when you say you pierce a hole in the straw, what will happen? Air will displace the vacuum and the liquid will not come up from the siphon pipe, from the pipe, okay, the straw. So that is what the concept of siphon breaker is. So you can see there is a valve made out here. So this valve, what it is doing is, it is actually opening this line to air. That is what the siphon breaker effect is. Why it is given? So you can see there is an accidental chance, there is a distant possibility that maybe these valves are not holding, and say accidentally there is a chance of water coming in from this side, okay, into the OWS, or the oily water going into the sea from this side. Okay, that is why you always see the OWS discharge line will be always have a head and then it will go out. Okay, so that is why you can see there is a head provided. So water has to rise up this head, overcome this head, and then it will be able to go out. And then also it has got a siphon breaker which will not let it create vacuum in this line, so that this line cannot take in the water from the OWS, or water from the other side, seawater cannot come into the OWS. Okay, that is why the siphon breaker is provided. Second question is, why do we have a CI and PI? What does this mean? In the bilge pump or the sludge pump or any pump which takes suctions from the double bottom tanks, you will have, or the low sea chest which is below the level of the tank, you have got a compound indicator and a pressure indicator. Either it is a fire and GS pump, or it is a bilge pump, or a sludge pump. So the purpose here is, the suction gauge you can see will always be a compound indicator. The discharge gauge will be a pressure indicator. Why? Because the compound indicator indicates the negative pressure also. That is why it is called compound. So it is vacuum also and pressure also, pressure side also. So you will see a value below 0 also in the compound indicator. Why it is given? Because there is a because we are taking suction from the double bottom, the pressure will always be negative. Okay, the head is negative, so pressure will be negative when you are taking suction from the double bottom tanks. If it is 0, that means somewhere air is coming in the line. Okay, and why in the discharge side you have pressure indicator? Because your pump will press up the liquid, so it will always have a pressure, it should have a discharge pressure. Okay, so compound suction gauge is having negative pressure. That is why you will have always a compound indicator installed in the pumps which will take suction from the double bottom. Okay, the next question in this section is, why do we have this one? Okay, so in the block diagram we had seen the components in which we did not have this special component here. So in this pipeline, or in this system, we have got a clean drain tank also. Okay, so this system has a separate component which is clean drain tank. This is just like your bilge holding tank. It has got contents coming in from areas where oil mixture cannot be coming in, like your clean drain tank combing, air cooler drain tank, okay, clean drain tank combing, board, starboard, these sections. So if you have drains coming in into the clean drain tank, which is a 25 meter cube tank, smaller tank, in that tank there has been provided a special type of pump which is called clean drain discharge pump. You can see this is apart from the bilge pump and the OWS system, you have a special system here where you have clean drain discharge pump, which capacity is 10 meter cube per hour, and it has got a head of 20 meter head it can pump. Okay, it has got also the priming unit from the freshwater hydrophore system. Now coming to the clean drain tank pump or the clean drain tank discharge pump also has got a bilge alarm unit, 15 ppm bilge alarm unit. So it will, what it will do, this bilge alarm unit will directly check the oil content if there is any in the water in the clean drain tank, and it will either send it to B where the B goes. If there is oil content 15 ppm or above, it will send it to the B section, which is the bilge holding tank. You can see it is sending it to the bilge holding tank. If it is having content of oil which is less than 15 ppm, so you can see bilge alarm unit 15, it will give an alarm and send it back to the bilge holding tank. And if it is less than 15 ppm, through the BA line 41, it will send it to overboard. So this symbol here is an overboard symbol. So this will send it to overboard. So apart from OWS, this system also has got a clean drain tank which can discharge directly into the sea with the help of the bilge alarm unit. Okay, now next question here is, why do we have this LAH MCLS? What does this mean? What is LS? So you must be remembering in the section when we were discussing symbols, we had discussed LS stands for level switch, and how is it different from the level transmitter. So level transmitter is just giving you a level transmitter is just giving you a value, okay, but level switch, what it does, level switch will indicate a complete a electrical circuit. What circuit it will complete? So you can see the two boxes here, LAH, MC and LS. So LAH is level high alarm, MC is the alarm comes in the main control console in the ECR, and LS is level switch. So when you have a high level in the port bilge well, at that time this level switch will complete this alarm circuit and you will have a high level in the control console, main console. So that is the purpose for this level switch over here, to give you a high level alarm. Same level switch you will find in all the bilges. You can see here, forward a starboard bilge also has got a level switch. Also your main engine recess has also got a level switch. Okay, even your clean drain tank has got a high level switch. All the tanks will have a level switch. Bilge holding tank has also got a level switch. In fact, it has got two level switches. One is for the bilge holding tank high level LH, and one is for the bilge pump stopping. So if you have bilge pump running for continuous period of time, there is a level switch which will indicate the level of the bilge holding tank has gone down. In that case, it will turn off the bilge pump so that it does not run dry. Okay, so special arrangements have been given in some kind of vessels to accommodate for any such instances where your bilge pump is cannot run dry. So these were some of the questions in the why section. Next section when we are meeting, we will meet for some troubleshootings related to the bilge system. Okay guys, thank you.